Hi, everyone. Thanks so much for having me. I've really enjoyed the day so far, and I'm delighted to be speaking here. I'm an associate professor at the School of Information at the University of Texas. That's my main job. I also moonlight at Amazon as an Amazon scholar. I'm actually the only academic that's sort of embedded in the team there that's in charge of Mechanical Turk and other things. So I'll just give one quick shout out about that and then kind of go on with sort of the academic stuff. Let's see here. Yeah, so our team is under Amazon Web Services. We manage 3 products: Mechanical Turk, Ground Truth, and Augmented A2I. So brief things to say is if you have trouble finding people at Amazon to talk to about Mechanical Turk, feel free to give a shout out to me and I can help connect you with the right people. There are also research awards that they provide cash and AWS credits that we fund every year. So that's also an option to know about. There's options for faculty interested in summer, sabbatical, or longer engagements with some links here, and also lots of opportunities for internships and full-time work. And I'll put my slides online afterwards too, so anyway, you can take a look at that.
Are you sharing your slides right now? I don't see them.
Oh, thank you. Well, what do you see? Let's see. I'll try. Sorry, Aaron.
Yeah, I believe I see them. I see something that says human in the loop services.
Yeah, okay. Great, okay. So I'm gonna keep on going then, assume they're visible. Okay. The other quick thing to say, so I and a lot of the researchers I know coming maybe for a computer science background have been working in this conference called Human Computation and Crowdsourcing. The first one was 2009, where we had 4 years actually of workshops, and the conference has now been going on for quite a while. There's one coming up in a couple of months. So this is really a great community where people talk a lot about these issues around data quality and assurance and various things. There's been a lot of really interesting tools and support that have been created there around supporting surveys and behavioral research more generally. So I'm going to be talking about some examples of looking at data quality, particularly for free-form text responses. So imagine as a very simple example, I might ask people, what's the capital of Texas? I might get 3 responses like this. And the classic thing we would do is do something like majority voting, trying to figure out what we think is maybe the right answer in a question like this, where it's an objective task, we think with a correct answer. So for something like this, you could say 2 out of 3 people say Austin, you might think that's the right answer, say. And if you look at, though, a much wider range of tasks, this is the sort of thing that people in computer science have typically been thinking about in terms of creating labeled data sets for training classifiers or evaluating them. So if we have just a couple of categorical responses, this could be like sentiment analysis or assigning images to categories, multiple choice questions, where we're trying to sort of say best out of A through E for a given question, ordinal rating tasks, etc. And so this is used in sort of crowdsourcing context when we're trying to sort of evaluate, we're trying to put together, annotations from less reliable annotators, but also even say with medical annotations from doctors where there's not really a right answer, but we want to try to reason about the best wisdom of crowd answer across a group of people. So typically, again, my work's been in this space where we have an objective or correct true answer. But sometimes things are much more open-ended. We often refer to these as subjective tasks. So you might ask someone in this case to transcribe an image, and you get lots of different, or not transcribe an image, but sort of caption it, you get lots of different responses. And the thing is, what do you do in this kind of case to reason about, either what's a right answer or more generally, what's sort of a normative answer or what's an outlier answer in this kind of space? So this is the kind of thing where majority voting is classically employed, falls short because the space of possible options is so large that you can't do simple things like exact match. And more generally, if you look across the kinds of things that people are doing in annotation tasks, there's all kinds of stuff like this, that these sort of simple models for putting different responses together don't work. So if you ask people to rank, say, the top 10 US imports, or to make some complicated linguistic structure, or to say mark spans of text doing highlighting tasks. So the work I'll be talking about today, this is what my PhD student, Alex Braylon, has been leading. The URL for his GitHub repo is going to be at the top of the slides for the rest of the talk. It's available with a very permissive license, and hopefully it'll be useful to some of y'all. So order of the talk, I'll talk a little bit about some prior work in this space, what we're doing, some example outputs, and I'll wrap up. So in that human computation and crowdsourcing community I mentioned earlier, there have been hundreds of papers on people trying to have very clever models for reasoning about response quality and combining things together. But typically they're all on these sort of very simple classification tasks, like say there's a set of categories and reasoning about what the right answer should be. When you try to look at these sort of more complex tasks, we're talking about, say, open-ended text responses, just essentially none of these things work. So what people have done instead is sort of for a variety of like more complicated annotation tasks, for every different task they think of, they come up with a new complicated model, which is great if you have time to run like a different model for every different thing you want to do and come up with all these things. And so the idea is, just like for these simple tasks where we sort of have one model that works across a lot of things, it would be nice to have one model that just works across a lot of different kinds of responses you might get from people. So that's the goal of the work we've been trying to do, is to have sort of a way to kind of reason about, again, response and respondent quality across lots of different kinds of tasks in a very general way. So talk about our approach. So the key insight we have is that sort of for every task we're looking at, people have what are called sort of evaluation functions or distance functions for reasoning about sort of how close together two responses are. So if you have an objective task where there's a true answer, you might have an evaluation function for saying how closely an answer matches the true answer, or just simply you have two responses and you can reason something about how close they are. So what we're going to do is we're basically going to take any kinds of responses we get and we'll map them into sort of pairs of distances and do all of our reasoning about that. So basically we get these distance functions off the shelf and then just apply them. And so I'll be focusing on these free text responses or survey questions in this talk today. So here's our example of this cat eating the donut. You're going to get 4 responses like this. And what we'll do is sort of compute pairwise distances between all responses. So in this case, you'll have some distance function. I'll say something more about this. And you might see that all these ones that look kind of similar will have small distances between them, small numbers. Whereas some other one that's very different has some very large number in terms of how far it is away from everything else. And that's sort of the basis of reasoning we'll be applying. So to give a couple dumb examples of distance measures. So a classic thing is called Levenstein distance, where you sort of look for 2 different textual strings, something about how many edit operations you would have to perform to translate one into another. And this, for example, is done at the character level. What we're sort of doing at more of the fancier natural language processing work these days is there's all this stuff on transformer models. You might have heard people talk about Muppet models because everything is named now like Bert or Elmo or Roberta or things like this. But basically in these spaces, what you do is you take text and you sort of map it into this high dimensional space where you basically start to see a lot of interesting relationships emerge. So as this sort of toy example shows, you'll see on a lot of NLP slides, you can see that in this particular space, you not only see that maybe queen and king and woman and man have some relationship, but also you could say map between queen and woman and king and man or something like this. So the idea is that you could ideally go into some kind of semantic space where you can look at distances between items. So from the framework I'm talking about today, sort of we don't care about what the distance function is. You can plug anyone in and that will sort of change the results. And the intuition is the better distance function you use, maybe the more semantic one, the better results you'll get at the end. So general properties of a distance function, this is a little bit of math for a second, is you typically want to talk about relations are non-negative, so distance should be greater than 0. It should be symmetric, so distance is the same no matter which way you measure it between 2 things. Some of these measures we work with actually are asymmetric, but you can symmetrize them without much work. And this notion of the triangle inequality, and again, not too interesting for today's talk, but to say, we can take sort of mild violations of these things and still stuff works nicely. And so just showing on this slide very quickly for text, there's different other distance measures. Again, I'm not going to talk about today, or all these for different tasks have sort of different distance measures you can apply. So what we're going to do is calculate these kind of distances like I just talked about. And the idea is you can do that across all of these different kinds of task types. And at the end of the day, you just end up with a distance matrix here. And so that distance matrix on the right-hand side is the thing that is the core of what we'll be reasoning about in our actual model. So now that we have these distance matrices, what do we do? And so I'm going to talk about some set of examples here where the current item, so you imagine this is a current question in which, a survey question in which we have some free text responses. So the current item is shown here in blue, and you might imagine that there's some particular annotator here shown in green, and we can see a history of other questions he's answered, maybe earlier on the survey or on past surveys. So you can see the same green guy showing up in past things he's done in the past. So I'll talk about 3 methods here, which will make more sense kind of as I go through them. So this first method is a generalization of majority voting. So this is sort of the simplest and easiest to apply and probably good enough in many circumstances. So what we do is for all the responses we have on a particular question, we compute, again, we have all these pairwise distances between them, and we just say for any given response, what is its average distance to all other responses for the same question? And the idea is the thing that is most similar to all the other responses is sort of most normative, or whatever is sort of least similar to all other responses is sort of the most of an outlier for that particular question. So this is a local approach because it ignores anything about the history or the particular people answering the question. It just sort of says for the current item, let's look at, see how each of the responses relate to one another. So there's total independence between items. You don't have to do any kind of training or modeling across items or history. But there's also, no notion here, again, about maybe if some participants are more insightful or less reliable or something than others. So the other extreme we have, this is the global approach, which we call best available user. And so in this case, can you imagine for a given response, we can see, for a given question, we look at the responses and we see how close you are to sort of everyone else on that question. Over an entire data set, either that's a single survey of many questions or many different surveys, whatever, you can kind of build in general to see a pattern, a profile for each person about how close they tend to be to other people. So do they tend to be more normative? Do they tend to be more of an outlier? And then what you could do is on any given single question when somebody answers, you could just look over the set of people who answered it and say which person tends to be most normative on average, or which person tends to be the most outlier on average. And then reason something about, again, how the quality of their responses or the normative nature of their responses, sort of just based on their history. So basically really ignoring everything they did on the current question they're answering and just seeing kind of what their historical tendency has been. So this is a nice global approach because you can see this person in like the past history items tends to be most central, but it might be on the particular item here shown in blue that this person is maybe far away from everyone else because we ignore that. So ideally what we'd like to do is sort of get the best of both worlds here. So we'd like to have this kind of history-based assessment of what the person's done historically, as well as looking on the current item, how central they are. And I want to build on this sort of very rich history of modeling we have on this in a crowdsourcing human computation community on these Bayesian models for reasoning about annotations, but generalize them to support these distance matrices we're talking about. So I have a bit of math for a couple of slides, but I'm going to try to sort of give nice pictures to go over everything as I do. So the key technique we're building on is called multidimensional scaling, which has been around since the 70s, so forever. But what we're doing is, whereas multidimensional scaling is over sort of a single distance matrix, we have a set of distance matrices. There's one distance matrix basically for every response, every question being asked. And so our approach we call multidimensional annotation scaling, or MAS. And so this is going to be, again, based on multidimensional scaling, but we're going to turn it into a hierarchical Bayesian model where we have some priors for reasoning about sort of past behaviors. And in general, we want to sort of have some shared parameters across responses. So the first part of when you have a Bayesian model, there's the likelihood term. This is the part this is sort of vanilla multidimensional scaling from history. So for this current observation, we have this current response where we have these captions for the image. We want to take these observed distances we see about how far the responses are and project them into some coordinate space, some embedding, such that the responses that are observed to be close together are very close together in this sort of embedded space. So you sort of imagine we warp the space like this such that things that are observed to be close together are close together in sort of this embedding space, and this one that's far apart kind of becomes far away. The second part where this starts to become new is where we introduce this prior. So we sort of assume at the origin of this coordinate space is the sort of most central ideal response you want to have. And then the model basically penalizes the number of responses that are sort of far away from this. So if you have a bunch of responses that are all really similar to one another, the model is going to want to pull them closer to this origin because it'll pay less penalty versus this one that's farther away. So again, I'm going to skip a lot of the mathy stuff. And so these terms that are sort of all clustered together get sucked in to be closer to the origin. But we don't have anything yet really saying something about this sort of annotator reliability or sort of trust. And so that's the last thing, this sort of gamma term. So again, I'm not going to assume necessarily correctness. This might just be which annotators tend to be most normative, most like everyone else, which respondents are most like everyone else historically versus ones that tend to be outliers. So the smaller this gamma score is the one people who tend to be sort of most normative, most like everyone else. And so again, what we're going to do here is say that smaller gamma scores should be pushed closer to the origin, whereas farther ones should be pushed farther away. So we sort of take advantage of the sort of reliability parameter for the annotator or respondent. And so that gets sucked in a little bit closer. So now normally when I give a talk, I normally have lots of nice experiments and data and results. And this is like the space I normally work in where I have these objective annotation tasks. So in this talk, what I'm doing is taking the same stuff that we have done in this space and trying to show for these kind of subjective survey responses how it might be used, as hopefully maybe a starting point for a conversation with folks after this about ways we might explore some more of this together. So here I've got, I think, 4 or 5 of these responses, but I'm just going to show you some actual quick data about this. So here's, I guess, 7 or 9 responses where somebody is, people are providing these different free text responses. And we have 2 columns. So the right column, which is the one that's used to sort the responses from most normative to least normative, this is our fanciest model that's looking at both the history, the global, as well as sort of the local what's happening on. And then I also show in the center column, the SAD model. This is the one that's only looking at what's happened on the local response. So you can sort of see they were going to order things in slightly different ways. But the rough thing you can see here, again, giving a flavor of this, is sort of the ones that are most like each other, that are sort of most normative, are going to float near the top of our ranking here, whereas the one here that's kind of the least like these others is going to float down towards the bottom. So the top here, we see he always speaks ill about his father. He always speaks ill of his father. He always talks about his father. Whereas there's one down at the bottom about he always talks about his dad behind his back. So the numbers, I would say, aren't too meaningful. Like, I don't think there's an interpretation you want to assign to the numbers shown here, but I think they sort of give you roughly a notion about how far or close things are. So just a little more signal than just looking at the ranking alone. So here's one more example here. So please be sure to take a note of what she says. Please take a note of what she says. Be sure to take a warning notice of what she says. These start to be a little bit farther away until you finally have at the bottom here something about, please, make sure to insert a disclaimer about what she says, or something like this, memo. As long as you stay quiet, you can stay here. You can stay here as long as you keep quiet. You may stay here if you keep quiet. Versus the bottom, you may be here if you keep quiet. Go ahead. Please go ahead if I'm late. Please go ahead if I'm late, if I'm delayed. And then at the bottom, if I should be late, go without me. And I think one last one. Actually, they are not married. To tell the truth, they are not a couple. To tell the truth, they are not a married couple. And then down at the bottom, 2 people are not couples in truth. So that's just some sort of examples output. So with that, let me just sort of wrap up. So we have this probabilistic model. Again, the problems that we've been hitting it with this hammer are these objective annotation tasks, mostly where we think there's a correct answer. But I think there's utility here in looking at these space for sort of more of these subjective freeform questions. So the work I just showed was with a very simple distance function, really where we were just looking at simplistic distance measures. So I think there's a lot of more flexible, interesting things with more powerful distance measures we could use, but haven't yet. We have a couple models. We have this open source thing with a nice permissive license. So again, where we're going is to more subjective tasks. I think it'd be interesting to do, again, some actual evaluation on survey data with behavioral scientists to see if this stuff is useful at all for folks in practice, and to kind of look at some of the different distance functions or model settings we could play with to maybe make this more useful. And we're also doing some work that I'm not talking about today about looking at detection of consistent biases in participant responses kind of versus what's most group normative. So with that, here are the two key papers for my students' work so far. The one at the top is the main one I talked about. We really appreciate the crowd who provide a lot of the work and annotations that make our research possible. I've got some notes here for the sponsors. Thanks for having me here today.
All right, yeah, if there are any questions, then we can move to Josh's talk.
Okay, so hi everyone. My talk is about data quality and detecting poor data quality and inattention, not just from explicit questions, but from implicit as opposed to explicit attention checks. So let me just start with a little bit about me. Right now, I'm an assistant professor in the computer science department at Student College for Women. My research interests are in computational linguistics and natural language processing. And what really interests me the most is the parts of NLP where you actually have to know about the linguistics of it, instead of just making, using machine learning, deep learning, coming up with a bunch of features, throwing everything at it, and a lot of data and seeing what comes out. But I have interest in machine learning and deep learning and digital humanity, social network graphs, and so on. And I've worked on various projects with CloudResearch. So let's start with a little bit about data quality. So a lot of this was covered in the first session. When we talk about data quality, there's many things that we would consider to be a bad response. And so, for example, somebody presents totally random answers. Let's say they're choosing from multiple choice, so they'll just click randomly, or they'll give nonsensical answers to a question, or they just don't know a lot about the topic, and so they'll give an ill-informed answer. Sometimes it'll be computer-generated answers, and you want things from actual human beings. We've had issues with copied answers, duplicated efforts. The same person is filling out the survey multiple times, or they'll see somebody else's answers and copy and paste it. So you might want to use plagiarism detection. They could be distracted for many reasons. Either getting tired, or they have multiple browser windows open, or just lack of effort. So what we'd like to do is detect that somebody is providing poor answers or inattentive. So again, it depends on what exactly you're trying to detect. And on certain types of fixed responses, it's pretty straightforward to detect. So here's an example of a CAPTCHA. Or if you want to see if somebody's paying attention, so an example from the first session, right? You could say, in the comment, please say thank you. Or at the end of this paragraph, even though it says no, even though you should say yes, the correct answer is no. Or just a simple question, are you paying attention? If you're trying to filter out people from specific areas, like you're expecting people from within the US, and really it's a server farm someplace else. So maybe you could do IP detection, but people will mask their geolocation. You could detect how long before they selected an answer. There are these various straightforward approaches. There's also, here's an interesting paper, and Labe is, if he's here, could talk more about it. In order to detect attention, So they developed the SDP, the squared discrepancy procedure. And what they did was they gave at the beginning of the survey a bunch of the 10 big five inventory items. So they would ask, how would you describe yourself? I see myself as someone who's talkative, and rate yourself from 1 to 5. Tends to find fault with others, does a thorough job. And you could really look for consistency even within that. So like somebody who's talkative could often would not tend to be quiet. But what they did in this particular study was at the end, they appended the reverse of 10 items. So you could start with, I would see myself as someone who is talkative. And at the end, they would say, I see myself as someone who is not talkative. And so you would expect that somebody who is paying attention, who isn't just randomly clicking on these little boxes here, would be consistent. And so they then examined the difference between these responses. And if somebody's highly consistent, so then we could say that they're highly attentive. And if they're not if they're not consistent, then they're much less attentive. Now, a slight problem with approaches like this was a quote from Abby Hamill, made a great comment in the first session. She said, what are your thoughts about research stating that attention checks may actually harm data quality? And she gave a link. And this actually is an issue that they, if you look at that article, so for example, if you're answering this big field of questions at the beginning, so that's gonna maybe make you more bored. And so later on, you'll answer with less attention. Or just the fact that you know that you're being monitored for attention is going to change the way that you answer it. So it's better if we could come up with some ways of implicitly testing for attention. And so there's all sorts of features that with JavaScript embedded in web pages and with NLP, so we can really accumulate a whole bunch of features. Now, it could be you just collect all of these features, you throw it into some machine learning model, and it comes out with something. But hopefully, we could look at specific features and see something that would contribute to the specific things that we're trying to find, like attention. So, for example, in keystroke dynamics, you could detect how long somebody has their finger down on each particular key, how long it takes before they hit a specific key, their typing speed, do they edit the text, and what kinds of edits they make. Now, a lot of this doesn't seem to have a lot to do with attention, but maybe some of it does. For example, let's say somebody was always pausing before starting the next sentence, right? Before they do period, space, and then the capital letter at the beginning of the next sentence. Right? So that might tell you something about how they're thinking about the response, maybe. So in various projects, we've collected keystroke dynamics, but this has been used to detect stress, but also boredom and engagement. Right? If you know the person already, so you could see, are they speeding up, slowing down, etc. For user authentication, if somebody takes multiple surveys, you can see are their keystroke patterns similar. Another thing that we've been collecting is in specific targeted surveys is mouse features. So for example, this is one particular question, and you might have the prompt over here. So each little box is going to be different parts of the survey, and it looks here like the mouse moved down, 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 and then they started scrolling. So the mouse more or less stayed in place, but then moved off to the side and moved back until they finally got to the bottom and clicked on next. So we can track that if we wanted to, looking for unnecessary mouse movement. Somebody's bored, they'll start moving the mouse around or off of the screen. What's the idle time when they're not moving at all? How many clicks per second? Do they move directly to the target? That might be an indication of a bot. What is the speed of movement? I do this at least when I'm reading something. I hover over the text with my mouse. Sometimes I select it, and that gets people looking over my shoulder a little annoyed at me. But there's various things that people do with their mice, and you could generate a picture and maybe feed that into, let's say, a CNN, some kind of deep learning model to try to predict whether the user is paying attention. Here's other session features. Some of them are explicit, some of them are implicit actions that indicate something's up. Like, is the window always maximized, or is it to the side? Maybe they're playing solitaire on the side. Maybe they're copying and pasting to some translation software or to some site that will give them the answers. Is the window gaining or losing focus? You could actually detect Control-C, Control-V to copy and paste. Was the question text or the answer text copy pasted? You could check the timing, selection events, highlighting text, and so on. But then we get to NLP, natural language processing, for free-form answers. And it could be used possibly as an alternative to filling out this personality grid that's gonna get somebody tired or knowing that they're being actually monitored. So there's many different possible textual features, and it depends what exactly you want to look for. So just as an example, a while back, there was this thing called the Gender Genie, Moshe Capel and others, that they used it to, if they had text of a certain length, like 300 words, depending on the genre, they could detect with 80% accuracy if the author was male or female. And maybe we could use something like that if we have demographic info about the person. It could be a flag. That's some of what I've been doing recently, is building language models using recurrent neural networks to try to see if it matches either what we would expect, or to see if we have poor responses in free text. Can we build a model for a good answer or a poor respondent? So the question is, what are the features that are associated with a high quality as opposed to a poor quality respondent? And so let's say you're talking about attention. Does that mean they're paying attention at the moment? Does that mean that they're giving care or thought to their answers? Maybe, probably not, but maybe you would want to think about education level. So here's some, if you wanted to throw everything, including the kitchen sink at it. So here are some NLP features that we could use. So let's say simple word and sentence features. There's the Flesch-Kincaid reading level, which is based on how many words there are per sentence and how many syllables there are per word. So you could, so that's used to assess reading level, but also writing level, maybe how educated the person is or how much thought they put into the answer. The number of sentences, right? If somebody just says something, a very brief answer in one sentence, that's not such a great answer. But you have multiple sentences. Is it grammatical? You could check if it has correct spelling, punctuation. I've seen people look at the ratio of different parts of speech to detect emotion and so on and so forth. Right, like in the previous example for Gender Genie, was just really they looked at pronouns, the ratio of pronouns to articles, and were able to detect it. Or here's the one that I'm going to focus on for now, is relevance. Right? How well does the question correspond to the answer? How well does the answer correspond to the question? And I'll drill down into that in a second. So here's an example of one preliminary study that we did. We were trying to assess based on free-form answers. So we gave them the trolley problem, and there's many different forms of the trolley problem, but this is often called the fat man trolley problem. Imagine you're on a footbridge over some train tracks, and you see a train approaching on the bridge, and the train's out of control. There are 5 people on the track who won't be able to get off of the track in time. You know that the only way to stop the train is to drop a heavy weight onto the path, but the only available sufficiently heavy weight is one large man. Right, so here's called the fat man. Also watching the train from the footbridge, your options are either to shove the man onto the track in the path of the train, resulting in the certain death of that one person, or you can refrain from doing this, in which case 5 people will die. So what would you do in this situation? And so there's all sorts of variants of it, where you're pulling a lever to kill one person as opposed to killing that person directly. So you're diverting the train. Should you take action? What if you're not taking action and you're going to have one result as opposed to another? So these are sort of designed to make you stop and think for a bit, hopefully. Of course, these have been popularized recently on The Good Place, right? So people are already familiar with these questions. So what would you do in this situation? So you pose this to them, and they're supposed to read it and then give a free form text answer. Or another type of question is you give them a painting, right? Or cat picture, cat eating something, but here's a painting, and you have behind the scenes already a good text description of it. And you ask them in a few sentences to describe the painting. And so 2 features that we focused on among the others was what I call overlap and coverage. So we took the set of the words in the question and the answer, and there are 405 common function words like is, can, and the that aren't really so relevant. We then focused on just the remaining words and got rid of duplicates. And then we looked for the number of unique words in the person's answer that had some kind of relevance to the question. So how on point as opposed to tangential was the answer. So if somebody says trolley and the question was asking about trains, that would be similar to it. If they say apple, so it has absolutely nothing to do with it, it's an irrelevant word, and you can get a ratio there. And similarly, coverage, it's the reverse idea. So the question maybe mentioned many different concepts. So what percentage of the ideas in the question were addressed by at least one word in the answer? Of course, as Matt was talking about in the previous talk, so you can't, you don't exactly have you don't have the exact words. So and so there are ways of comparing various answers and have blue scores and so on and so forth. What we did was we looked for the word embeddings. So the problems are, let's say the synonyms. The trolley question used the word train and they say trolley. Instead of saying large man as in the question, they say fat man, or they say push instead of shove. So if you find related words, so then you could say, yes, this has been addressed, or associated words. So the conductor, or switch, or crush, and so on, none of those were mentioned, but they're sort of related to other words within the question. And so there's various ways of using it. We could look up the words, there's synsets in the WordNet lexical database, but we used word2vec, which represents words as n-dimensional vectors. One way of thinking about it is not exactly like it, but it's a distributional criteria to describe words. So a word is known by the company it keeps. So if you have the word king, so probably there's some probability the word throne will be within a window of certain words beforehand and afterwards, apple less likely. And so you make n-dimensional vectors with these probabilities. But really it's the output layer of a neural net training on, in the case of WordNet, 100 billion words, and the vectors do seem to capture meaning, sort of. You can drill down into the original paper, it's not exactly as they represent it, but there's a famous example is they take the vector for king and you subtract from it the vector for man, and you add to it the vector for woman. The closest vector that you'll find to it once you eliminate king itself is going to be the word queen. So it does seem to represent something semantic about these words. So here are some preliminary results of our study. So what we did, how do we know whether using these features actually is finding if somebody is attentive or not? So we made a survey that started with the SDP, right? The square distance, the discrepancy procedure with the questions, talkative, not talkative, etc. We labeled people who are attentive, inattentive, if they scored 1 to 2, neutral is 3, attentive was 4 to 5, and 44% were actually a class 4 there. Then just, and this is a preliminary result, just to see whether these features are useful. Right, I mean, there's some models that you could just throw everything at it and it'll hopefully use the features that are useful and discard the ones that aren't. But we still would like to know, are these features useful? So on the trolley question, using only our language features and not the various behaviometric features that we also had, using the Schusen-Street regressor rounding to the nearest integer. So we got some pretty good results in terms of precision. So what that means is if we labeled somebody as being inattentive, so inattentive, we got 54.55%. If we labeled somebody as being attentive, we got 73.2% attentive. So there does seem to be some correlation between the SDP and coverage and overlap in these other features, so that we can use this as an implicit measure if we include them on surveys. And just to drill down a little bit more, so we're not really interested in the particular ranks that we assign of, is it a 1 or a 2, and not really sure what a 3 means. But if you do drill down into the data, so if we're really sure that somebody was inattentive, or really sure that they were attentive, so in those cases, we never made an error. If we said, yes, this person is the most attentive, so we always labeled that correctly, or this person is really inattentive, so we always labeled that correctly. So that's all, folks, and if people have questions, I could try to field those.
All right, thank you, Josh. Lots of good stuff in that talk. There have been some questions posted in the chat. Scroll back to begin with the first one. Abby asks, with this natural language processing, how do you ensure that you're not tossing out actual participant responses in practice? Or do you ensure that you are not tossing out actual responses? I don't.
Right. So, I mean, this is right now.
Sorry, just
to
clarify, I mean like good quality participant responses.
Yeah. Right. So, right. In other words, people who really should have been labeled 5, etc. So this is all. I haven't tossed anybody out yet using this. Right now, I'm just exploring features which could be used, but it's a good point. You could end up tossing out some good people as a result, because they're right. It wasn't 100% precision, and it wasn't 100% recall, right? So we're not. But the point is that as we find more and more of these features that are useful, maybe combined together, you could reduce that. Right. So in other words, also we would like to include the behaviometrics and mouse movements, or if somebody seems to give a really poor result, and using 3 of our classifiers, and we also see a bunch of copy pastes that seem to indicate that they're getting it from elsewhere. So then that would be a good reason to throw somebody out. But yeah, otherwise it is a good concern.
Right, I think we probably have time for one more here. So there's a question about some studies show that synonym antonym pairs, which you talked a little bit about, and Mahalanobis distance measures, which look for multivariate outliers, that they do a pretty good job of detecting careless responses. And so the question is, what additional advantages do you think these machine learning methods would offer above above those kind of more standard traditional measures that are out there already?
So I don't have a ready response to that. I mean, the more you have, the more features, the better it is that you could choose to use one or the other, and maybe also if you can do this more implicitly without people explicitly detecting that you're testing for this.
Okay, so that's a good place to transition. I know there was another question in the chat. We'll save the chat and try to respond to those afterwards. But next up, we have Patrick, who will be talking, I think, about item timing data.
Good. All right, we're off to the races. I'm going to be talking today about some pretty simple stuff in comparison to what you just heard. Pretty low level. But it may have implications for this other bigger research that we've been talking about. And this is simply looking at item timing. Now, I am not particularly, I don't research online crowdsourcing things that much. I'm just working in psychology. This research came from some work I was doing on my dissertation, and so I'm just sharing some insights I got from that. So what I want to talk today is why in my particular personality research, I needed to keep careless responses. I didn't want to just say, oh, these are bad, throw them out. And then some problem I noticed with doing content-based measures of carelessness, which some people have shown some pretty sophisticated solutions to. And then also note that carelessness is not just a dysfunctional thing or data we want to throw out, or an invalidity indicator, but actually can represent a useful signal, a part of a personality that we may want to capture. So I'm looking at what I'm calling intentionally inattentive behavior to distinguish between unintentional inattentive behavior. And I'll talk about how I measure it, and then some correlates, and then another little bonus, a way I saved money on MTurk with a very simple quality control measure of ability. So my original research was looking at what I call exaggerated sense of ability, which is kind of like overconfidence or overclaiming, people thinking they know things they don't. Now, this, what I found was this actually was similar to general intelligence or IQ, but distinct, and it predicted academic performance distinctly from general IQ. So it was kind of about self-knowledge, but it related to carelessness. That's the complication. So I wanted to keep the people who appeared careless as an indicator of this exaggerated sense of ability. And this is my exaggeration measure that correlates with overall GPA, academic performance. And it has a similar negative relationship as general IQ does, but it's separate. So it's something that I needed to not throw out. Now, there's a bunch of research, and I won't go into it, people looking at carelessness and showing that, well, it actually is a valid indicator of something about the person you may want to measure. So you don't necessarily want to throw it out because you could be biasing your sample if you're trying to get, something representative of humanity in general. These people may need to be included depending on what you're looking for, which I was. Now, a lot of the techniques for carelessness, looking at, well, in the psychological literature, at least, not so much in the human-computer interaction stuff. A lot of it is based on the content of the survey responses, such as bogus items, or we call these, or some call it infrequency items. Stupid questions that people shouldn't answer in a certain way. So nobody should agree to, I slept less than 1 hour per night. That should be an impossible answer. One would think that, if they agree to this, then they are not being careful, they're not being attentive, they're not paying attention, they're not giving a sincere response. But they also may be in a grumpy mood and they didn't sleep very well, and now they're just exaggerating their insomnia. So if somebody is like that, then that kind of personality, I don't necessarily want to throw out. If that's their kind of person, that they exaggerate how they do things. Now, more sophisticated, which I think Joshua talked a little bit about, is like semantic synonyms or antonyms. So if you get someone who says, I love my job, later on, they probably shouldn't agree with, I hate my job. But of course, you know, humans might have this ambivalent relationship with their job. And so trusting that, you know, I'm a really talkative person, or I'm a really shy person, people will agree to both of those in a sensible, meaningful way that doesn't help you sort out who they are, what's going on. So it can be very frustrating that people have this kind of illogical response. Getting more abstract, you can have what we call psychometric synonyms or antonyms, things that aren't, you know, necessarily logically separated, but we expect people to behave, you know, respond positively to one thing or negatively to something else. And so you do it based just purely on the correlations between these items. And to be more sophisticated, as people mentioned, like Mahalanobis distance, you're going to look at the, you know, how far they are from the ordinary distribution of all those responses. The problem, I thought, conceptually, theoretically, with all these, I mean, there's validity absolutely to all these, and they're useful in different ways. But each of them assumes that a divergent response, a diverse response, is a deviant response, is a careless one, is an inattentive one, one that could be thrown out or deprecated in some way because it doesn't fit with what we expect, which means you can get to this kind of researcher bias of saying, I want my people to respond in a way I expect them to, and if they don't, I'm going to pathologize them as careless, inattentive, whatever. That may be over dramatic, but the point is, you may need some of these outliers. They may come from something other than what you think they are. So psychologically, you know, particularly in my case, I want some unusual people and I want to see what it means. So I was looking at, and Joshua talked about this too. Well, first of all, that invalidity may be attentive. People may be deliberately responding in unusual or creative or unexpected ways. So I'm looking here just at timing, just simply item timing, which again, Joshua and others have talked about, a simple behavior measure, not based on content at all. So there's some research showing that in this case, when timing for a typical, you know, Likert personality question falls below 1 second per item SPI, overall consistency in a response just plummets. This indicates, all right, they're going through things too quickly. Now, in that particular paper, they looked at aggregate time, like, you know, 12 questions on a page. Are they spending less than 12 seconds on that page, et cetera, or the whole survey? Now, of course, anyone in cognitive psychology will tell you, you really should not be using average timing. You should be looking at median timing. So you have to get individual timing. And also you can have people who, you know, zip through a bunch of questions, go to their phone for 10 minutes, come back, zip through the rest. Your aggregate time is going to be misrepresentative. So I just, I was using Qualtrics, so programmed some JavaScript. So what I did is I made skipping through questions quickly easy, so that they just tapped on a question and it automatically moved on. But I captured when they went too fast and I gave them a warning. So there's interactive in that sense. So in other words, I allowed them to rush through the responses, but I let them know that I knew they were rushing through responses, so they had to try. And my overall measure was the number of times they rushed through a response, took the square root because it's a very long tail on it. And over hundreds of personality items, I found 55% never rushed at all. And about 87% only rushed once or twice. Others would do a lot. So there was clearly a distinction there. And I got similar results that I'm going to show you, whether or not I did it as the square root of the number of rushes, or if I did it like, you know, rushed once or twice or not. So dichotomous. And here's a simple, very crude video of what it looks like. So someone's answering these questions and they're clicking through and it automatically advances. But if they go too quickly, and sorry for the herky-jerky video there. If they go too quickly, they'll get a warning. They're saying, you're probably going too fast. You're responding before you could read it. Because they are. It takes more than a second to read and understand a sentence. And so they can keep going. They got that penalty. But if they keep doing it, they'll get another penalty. So they get penalized each time. The problem, though, with this very crude approach is that the browser will eventually say you can turn off the warnings. But I still keep counting the number of times rushing, and it still slows them down a little bit. They cannot literally respond faster than 1 second. So that's what it feels like to do it, is if you're paying attention, you won't get any penalties, everything's fine. The more you rush, the more of an annoyance it is to you, rushing through. So this measure of impatience, I found a lot of significant correlates with overall academic performance. It's getting a negative correlation. And so that's an independent measure. So this suggests that, all right, this rushing represents something about the person in general. And some simple cognitive measures like a vocabulary test, number problem solving. This is based on the cognitive reflection test, which is a bat and ball cost $1.10, etc. Recognition memory, just remembering a list of words. Hindsight bias, the I knew it all along effect. And response consistency, if they, they had some a bit where similar questions embedded twice, and or an attention check, whether they answered an instructed question correctly. So this is capturing typical carelessness and also tendency to not really be thinking very much about what they're doing, or just not thinking much at all. Looking at personality correlates, I looked at the Hexaco, which is a 6-factor model, like the Big Five, kind of like, not exactly like the Big Five plus honesty, humility. And we can see that it isn't just a response bias in terms of rushing through, because we're getting slightly different correlates with the different dimensions. And the biggest one is this extra facet that comes from that Hexaco 100 called altruism. So what we're seeing, this is consistent with these other measures, is people who are rushing like this, intentionally rushing, are kind of jerks. They intellectual overconfidence, academic entitlement, receptivity to bullshit, they're gullible. Overplacement is a kind of overconfidence that's also known as a better than average effect. They think they're better than other people. And narcissism, this is a fixed choice, forced choice questionnaire. So it isn't about a Likert scale. In other words, to get a signal on a narcissism, the NPI, narcissism personality inventory, you can't, just answering randomly won't get you a signal. It'll get you a middling score. So in other words, what we're capturing here with this rushing is not just a response bias. This is something to do with real personality. So that's really just what I'm pointing out here, is that is a very simple measure of impatience can tell you a lot about a person that may be related to carelessness, or maybe more just about the person. So it can be an important individual difference. You don't necessarily want to throw these people out. Obviously, you want to have some metric for absolute garbage responses, but people who appear to be careless in general may be part of the population that is really relevant to what you're capturing. If you're looking at psychology and stuff, sometimes you're just going to look at, categorizing questions or something. And it may be relevant to your research question. So think about that. Do you want people who are narcissistic and entitled and whatever in your sample, or do you want to just narrow it down to a certain psychologically clean set? Because that's going to bias your sample, depends on what you're doing. So I would argue we don't necessarily want to discard people. We want to measure and control for it. And it doesn't answer the fuzzy question of when is it truly garbage, or is this just a strange, uncooperative person? And I would argue that survey engines in general should have better timing control and other behavior controls like a change of focus, which Joshua also mentioned. So I think overall, my argument is behavioral measures in surveying, if you're looking at things like psychological issues. Behavioral measures have a certainly cleanliness that content-based measures won't. So that's worth paying attention to. And a little bonus, one way that I saved a lot of money on MTurk, very simple quality control, is I warned MTurkers that college level English would be required in the description of the hit. I gave them multiple choice vocabulary questions that were timed, so they didn't have time to look them up somewhere else. And then I did a quick calculation. You can do this in Qualtrics, probably other places, to see if they were answering beyond chance. So in a group of 20 questions, they had to get at least 9 correct. And if they did, I just stalled the survey and I told them you needed to get rejected, but they also didn't get paid, which means I didn't penalize them, but they didn't penalize me, allowed me to pay them automatically on completion. And it saved me 63% of the attempts that tried to get through. So it saved a lot of money on MTurk. And the end result was a very good quality data set based on other measures I used, because they had to get through this ability test and show that they actually were paying attention and knew what they were doing. So very, very simple research. Hopefully that is helpful in some way. And thank you very much.
Yeah. Okay. Well, thank you, Patrick. There's a lot of good stuff in there. I personally enjoyed that talk a lot. So we have about 10 minutes here for question and answer. Again, you can drop questions into the chat or unmute your microphone and ask out loud. But we have quite a good chunk of time here for some questions.
Great.
Nice talk, Patrick. Just a quick comment while other people are gathering their thoughts. About 10 years ago, I went to some workshop with the CEO of Crowdflower, and he was talking about using this timing information to see if people were reliable. And then some worker sent him a picture of like a custom keyboard he had made for himself to be able to do the tasks faster, right? So for all this stuff, I think we're looking at trends, and figuring that most people wouldn't be able to do this. But the hard part is there's always outliers and people who get caught in the crossfire, like by any any protection scheme. And I don't know that there's any ideal solution for that. But there's always this challenge about, more broadly, trying to be transparent and accountable to the workers that we're providing potential screening to, in case we do something wrongly, for them to appeal and let us know about it. At the same time, that transparency opens us up to gaming. And at a conference I was at, there was discussion and basically people just didn't know how to do it. It's like, we'd like to provide that kind of transparency and accountable to people and kindness and fairness, but it just seems to be hard to do.
Yeah.
It's a tough balance. It might also speak to something that Josh brought up in his talk. About the use of the limitations of just the timing data. It's always good to have multiple measures. The more things that you can kind of triangulate, the better. So
I was fascinated with Josh's work looking at multiple behavioral measures, and I'd love to see those built into standard survey engines. Because if you're just a psych prof doing research, you can't look at all these different things. So I wish they were available.
A quick question, I may have missed this, and I apologize if I did, but you had the GPA data and stuff. So was this with college students or was this online?
Yeah, this is all college students. I did some this. There was sorry, I should have. Some of it was just college students. Some of it was with MTurk. And so I didn't have something like GPA for MTurkers. Right,
I assume that. It's interesting that with the timing to separate out this thing that might be people's personality versus in some online platforms, right? People who are more interested in kind of fraudulently or bad faith,
right?
Not just carelessness, but it would be, it got me thinking it would just be interesting if we could quantify, separate that out somehow, what percentage of people in online platforms kind of meet this personality characteristics that you're talking about versus the percentage who might be doing, something else and have really poor timing data.
Yeah, well, that's raises an interesting question, because you the psychological profile that I was targeting, that I needed to measure, may be exactly the kind of person you don't want in your surveys, because they exaggerate themselves, they're not honest with themselves, et cetera, et cetera. So in that sense, they are valid responses, but you still don't want them. So there's a compromise there.
It looks like there's a question here from Justin, and someone else says they have the same question. So Justin says, knowing that poor respondent behavior is caused by distinct personality type is useful and interesting, but if the responses are not quality, how to make their data useful?
That's a very good question. Well, this is the distinction between what we're calling a quality response and a divergent response. Yeah, you're making a distinction here between deviance or low quality. There's going to be psychopaths and narcissists and arrogant people, or creative people in your sample. It depends whether or not you want to include those in what you consider representative. Because sometimes, if you look over a lot of any of the content responses, well, even the examples they gave there, someone could be very creative in describing that Van Gogh painting, or the cat with the donut, feline hunger, that they may actually be a really, really good quality response, but they're deviant, as in they're too clever, or they're too creative, or something like that. There's going to be a difficult decision in dealing with translating diversity into deviance for all of these things. So I don't have any kind of happy answer. All I know is that in my research, I discovered that some unusual people were particularly valuable for a certain research, and it didn't work to write them off, because at one point in my data, I found that I was going to throw out a bunch of stuff. And then I realized I was getting effect sizes of 0.5 and greater with the signal I was looking for. So the data I was going to throw out actually had the signal that I was looking for. And I realized, oh, this is a very, very different approach. I can't throw out people because they aren't responding the way I expected. So not an easy answer, but just to say there may be a signal where we're not looking.
I just want to support that quickly. There's a lot of stories of people who apply, simple filtering things and throw stuff out. And there's actually lots of interesting signal there. There's interesting signal in the disagreement. There's outliers. And I mean, I've heard a great story from people at Google who were just doing, annotation about whether something was an airport or not. And they were sure the workers were wrong. And then it turned out when they zoomed in on the park, there's a small airport in the middle of this park, So I think there's all kinds of, great examples here where we just have to be really careful about that. And again, always remember that there's people at the other end who are affected by the decisions we make, particularly if you're not paying for responses. But, I guess often in the behavioral community, you're a little better about that.
Mm-hmm. Yeah, I think what both of all these points are kind of touching on is something that we advocate a lot for is really making sure that what you're doing is fit for the purpose of your research. And even with these things like data quality, it requires a lot of thought to sit down and think about what it is we're doing, what we're measuring, how good those measures are. And, unfortunately, most researchers are pressed for time. Scanning these things for data quality is not their primary objective. And so we like to kind of fall back on quicker heuristics, hard and fast rules that we can implement. But it really is worth the slower effort to think through things through. And sometimes, like you're saying, there might be signal in places where we're just kind of discarding. So it's always hard and requires a lot of thought, but it's something we certainly advocate for in selecting platforms, but also in measures of quality as well.